Hey, what's up, guys? Okay, so in this video, that I'm gonna to prove a so-called max-min inequality. Basically, I will start to show some serious video about like convex optimization and linear programming. Okay, so this one is very simple. Okay, so let me just explain it. So let's say let's say Z and W are this capital W are subset of n-dimensional vector space. So suppose I have a function from Z times W to a real number. I want then this theorem say the following. So if I take the infiniment, and the supremum, so this just tell you that if you take the infiniment and supremum, first take Z and W. So this fz and w, you will less equal to the if you change the order. Okay, so it should take supremum over z and then infiniment over w. Okay, so this is called max-min inequality. Okay, so notice that this equality may not hold. Okay, may not hold. Okay, so trivial example is that you take fzw to be a sign of z plus w. Okay, and it's trivial to see that for any z, right? For any z, that your infiniment, right? Because sign is like the sign is basically from -1 and 1, right? So you take infiniment over w for any fixed z, always gives you -1. Okay, and obvious that for any w, if you take the supremum of this sign z plus w, it always gives you 1. So in this case, that your this guy would be -1, then this guy would be 1. Okay. So this is why this equality may not hold. Okay, so let's write down a proof. Okay, so this proof is simple. You just think a little bit, and you will simply find the reason. Okay, so very trivially, let me just write the following, right? So I can just write this infiniment part. So I can write the inf of w belongs to w, fzw to be a function. Let's say this is called g of c. Okay, and let me write supremum of z belongs to z, fzw to be, let's say, h of w. Okay, so notice the following, right? Notice we always have g of z less than fzw and h of w. Okay, so this is basically trivial by the definition. Very trivial. Okay, because your g of z take the infiniment, right? So if I fix any z, if I fix any z, right? Then I take infiniment of w, it will always less than fzw for that zw. Okay, and this is holds for hw. Okay. Okay, so if I take the sup of z belongs to z, g of z, you always less than equal to sup of z belongs to z, fzw. Okay, now right, so this is copied from here. Okay, so now let's say here. Okay, from here, right? So this is true. So if I take the maximum of it, you always less or equal to the minimum of it, right? So if I take the strip of z belongs to z, fzw, then you always less or equal to hw. Okay. If okay. So this is basically you can view that this is the ZWF. Right, so any function, any results on FZW always less or equal to h of w. So it means that the supremum of this guy is always less or equal to the minimum of this hw. Or simply speaking, you can just take these two and then say that you write the supremum of this or less or equal to the inf of it. Okay, so from here, Then finally, you can get strip of GZ. Z belongs to Z is less or equal to inf of W belongs to W, H of W. And then this is basically the proof. Okay, see you guys next videos.